I can say with confidence that continuous delivery as a software development approach works better than any alternative that I've ever tried or seen. And I've tried most of them. It doesn't matter what kind of software or at what scale, it just works better. The problem is though, that although at its heart it is a simple idea, this is such a radical change from what most organisations do that often people don't understand the impact that it will have until they get to see it in person. It's almost always a lot better than most people who have never seen it think it is. So it's obviously delightful for me when I meet someone who has been through that process of seeing the difference. Brian Finster is one of those people, and by virtue of our shared experience and strong belief in the value of this world-class engineering approach to software development that is continuous delivery, we've become friends over the years. Brian led a change at Walmart, the world's biggest retailer, and recently wrote about it in a fantastic post on InfoQ that describes some of the aspects of that complex journey and what it takes to change the development culture of tens of thousands of people working on tens of millions of lines of code. Typical of Brian, it's provocatively titled and opinionated, replacing process dogma with engineering to achieve true agility. How did Walmart go from sometimes less frequent than annual releases, starting with just one of many multi-million line code legacy systems, to daily deployments for nearly everything? How did they scale agile without a scaled agile process? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well. I said in my introduction that continuous delivery is a simple idea, and that may sound confusing because you have to do many complex things to achieve it. But it is simple in that our goal is simple to describe. We aim to work so that our software is always in a releasable state. I know that I repeat that phrase a lot on this channel, but it really is the core of what we're talking about. If you optimize everything that you do so that you can correctly see whether your software is releasable or not continuously, then whatever it is that you're doing is working and is good. That means that this is a tool that we can use to drive change, to help us to decide what to change at each step of the journey to improve things. This is exactly what Brian and his team did at Walmart. Brian was working as part of a supply chain team there. He later led a key platform team that was responsible for helping to roll out these now tried ideas across the whole of Walmart to tens of thousands of developers. But the story really started when the VP in Brian's area of the business got inspired by reading Gene Kim's The Phoenix Project. This is easily done, it's an excellent book. Walmart had suffered lots of failed agile transformation projects by this time, mostly based on SAFe. And in most cases, they ended up delivering less often and with bigger failures than they had before the transformation had started. The Phoenix Project is a novel in which the hero saves the company by adopting a consciously lean approach to software development in his organisation. And it seemed to be recommending a very different approach to what SAFe was describing. So the VP tasked a group of good tech leaders to make all of this work. Brian was part of that group. Let me pause there and say thank you to our sponsors. We're extremely fortunate to be sponsored by Equal Experts and Transfic. Both companies offer products and services that are very well aligned with the topics that we discuss here every week. So if you're looking for excellence in continuous delivery and software engineering, do click on their links in the description below and check them out. This episode was inspired by an excellent InfoQ article which I mentioned in the introduction, written by Brian recently, and I encourage you all to go and take a look at it if you would like to learn more. There's a link to that in the description below too. The software that Brian's team started with was an amalgamation of 4 big nasty legacy systems that together totaled more than 25 million lines of code, so servicing around 800 different applications, looked after by around 400 developers. Brian said in his article that calling the architecture of this system spaghetti would be a dire insult to pasta. Fairly early on, the group got inspired by my book, Continuous Delivery, and decided that that was what they wanted, and to achieve it, they would take the principles of continuous delivery to their hearts. Instead of aiming for some kind of grandiose agile transformation, they instead focused on, why can't we deliver today's work today? Every time they identified something that got in their way of being able to do that, however complicated or entrenched that thing was, they worked to eliminate it, optimize it, or to go around it. This is at the heart of the continuous delivery approach. Keeping our software in a releasable state takes precedence over everything else. So we use that as a target to direct our efforts. After all, this is the core of what really matters, whatever the nature of the system that we're building. What's the point of software development if you can't release your code? The DevOps movement gave them more ideas about how to improve their development culture. A key part of working so that your software is releasable is being able to tell if it is ready or not to go into production. And making that easy is key. They realised that organisational structures and team boundaries placed limits on being able to see where they were. So they couldn't easily answer questions like, is it releasable, without huge amounts of work. This placed severe limits on the speed with which they could make changes. Bureaucratic structures and complex chains of command limited their ability to change. So they changed the bureaucratic structures and the complex changes of command until they were organised around smaller, more autonomous teams instead. They used ideas from domain-driven design, in particular bounded contexts, to help them to better understand and break their system down along business lines into less coupled, more autonomous pieces. Inevitably, after they'd done this, the software didn't really match that model, but that's the next part of the problem to fix. First, get Conway's law working in your favour. They aligned their new autonomous teams with bounded contexts to help them to become more autonomous. And each team then started to work to better represent these boundaries in the code and protect them with better defined APIs and contract testing. The combination of all of these things meant that now each team could make change more independently than before. They were genuinely more autonomous. This meant that the feedback was now much faster, because now each team could collaborate within the team and run all of their tests locally along with the contract tests of the teams whose code they collaborated with. So, if Team A made a change which invalidated the assumptions made by Team B, who used the services produced by Team A, Team B's contract test would fail in Team A's build. So now Team A could fix the problems that they'd caused with their change, or talk to Team B about how to proceed. Mostly though, Team A could fix this for themselves and so make unhindered progress. All of this meant that as a result of working to speed things up, they were forced to implement more clearly defined boundaries between parts of the system and between the teams supporting those parts, which in turn forced them to improve the autonomy of those teams too. Because without that autonomy, they would have been back to having to coordinate the work of many interrelated coupled teams, which is always slower and lower quality. The result of all of these changes was that to achieve this autonomy, they were really forced to address architectural and design weaknesses in their systems to better compartmentalise them. So as a side effect of working this way, they were pretty much compelled to make systems that were easier to work on, easier to test and easier to change, and easier to release. They were now higher quality systems. It's a common misconception that when continuous delivery people like Brian and I recommend it, we aren't saying that it's some kind of magic fairy dust that you can sprinkle over any system or team structure, however terrible, to make them work. It is instead an engineering process that forces us to address the mistakes that we have made previously and that are getting in the way of us doing a really good job. Continuous delivery works better for any technology, for any type of system, but you will still have to change a lot of things to make it work if you already have systems in place, including things like team structure, team roles, responsibilities, as well as design, testing approach, and automating deployment. The guiding principles of maintaining our software in a releasable state and doing everything necessary to achieve that has a very broad implications, and the deeper you get into it, the more forceful this idea becomes. Next in Brian's list of steps was to optimize for operations. The example he gives in this article echoes very closely something that I often tell my clients. Brian points out that in the bad old days before continuous delivery, Walmart, like many other big companies, would have a series of procedures in place to deal with serious failures in production. like nearly every other organisation that I've ever seen, as a disaster gets more serious, the more normal safety controls and procedures are relaxed. No more change approval boards or sign-offs of staging releases, often no more pre-release testing. At the most serious end of the spectrum in disaster, when your production system has crashed and is currently bleeding money, what do? Most organisations cross their fingers and hope that they don't break anything worse than it's already broken. Or, to put it in Brian's words, this means that the handoffs we had for testing for normal changes were bypassed for an emergency. Then we would be in a dumpster fire hoping our bucket contained water and not gasoline. In continuous delivery, our aim is to implement one definitive route to production for all changes, and then optimize that to the extent that we can use the same mechanism even when our system is down and bleeding money. Because in reality, that's when we most need the protections that our deployment pipeline has automated. Making the deployment pipeline definitive for release, whatever the nature or cause of the release, is another of those important disciplines that helps us to see the wood for the trees and focus on what really matters. That our changes are safe and we're not going to make things worse. This then forces us to optimize to reduce the cycle time, giving us fast, clear, definitive feedback at every step in every context. But for that to be definitive, it forces yet another discipline on us. We must evaluate deployable units of software, because otherwise we're only guessing. So again, the work that the Walmart team did at the start of establishing sensibly autonomous teams with better bounded services and components adds extra value, because their work is not technically or socially coupled and dependent on other things. They can make changes in the confidence that if all of their tests pass, they can release those changes without any more work to do. This depends on a lot of things that I've described and a few others that I've skimmed over, most notably a sensible, effective strategy for automated testing that takes testing and quality way beyond depending on throwing changes over the wall to some separate QA team. QA becomes an integral part of the development process and a foundation of the job of software development. Walmart embraced this idea too with a very strong BDD-based approach. If you'd like to learn more about how to do that, do check out my free webinar on the topic of BDD and acceptance testing. There's a link to that in the description below. Brian summarised his key takeaways like this. Scaling frameworks don't work without sound engineering backing, or to quote another part of his article, engineering trumps scaling frameworks. But this also takes more than only being good at code. This is about the social structures at play in your organisation. The focus on daily delivery that is maintaining our software in a continuously releasable state is a key driving force to change all of these things for the better. Keeping our software releasable, even in the most challenging circumstances, takes high quality software and a high quality approach. Brian's last one is kind of sad, but also something that I've experienced too. A change of manager at Walmart undid some of the changes, the advances that the software development teams had made. Management changes, and often new management don't understand what they have when they arrive, particularly if they haven't experienced continuous delivery before. So it's very easy for them to undervalue something like continuous delivery that looks strange to them before they allow time to see its impact. Continuous delivery is a commercial advantage for the companies that operate it. That's not me saying that. That's one of the findings of the State of DevOps report, which has studied tens of thousands of software projects over years now. But if you've never seen it before, it looks very different, weird compared to how most software is built. So as a new manager, if you think that how most software is done is as good as it can get, you're wrong, but you don't know it. So now you may try to reshape the weird looking continuous delivery into something that's practically measurably worse. Or to quote the Harvard Business Review, the greatest impediment is not the need for better methodologies, empirical evidence of significant benefits or proof that agile can work, it's the behaviour of executives. So if you want to be able to keep this more efficient, better quality, more humane approach to software development, then we need to also make sure that we measure things so that we have the evidence that all these things are true, and so that we can make a valid case for them when we need to. Thank you very much for watching. I'd also like to thank Brian for his permission to use his excellent article on InfoQ as a basis for this case study. There's a lot more to the Walmart experience, significant things. I haven't even mentioned their excellent dojo program, for example. But there are several more links in the notes to other descriptions of Walmart's remarkable transformation. Thank you very much for watching. If you enjoy our stuff here on the Continuous Delivery channel, please consider supporting our work by joining our Patreon community. To those people that are already members, thank you very much for your support. And if you're not a member, there are lots of great benefits, including ad-free content and a very thriving Discord community. So please do check it out. Thank you.